Here's our next one. They're getting more and more complicated. I've already marked the terms in here. One term goes to the negative sign, the next, and the last. So we have 3 terms. In this position, we have a 9, 3 x's, 2 y's, and a z. In this position, we have a negative 3, 1x, 3 y's, and a z. And in the last position, we have 39, 1x, and 2 y's. All right, so now that we have all of our pieces separated, we can see them a little bit better. You're going to get used to this after a while, after you work with polynomials and taking out the greatest common factor. You won't have to list this anymore, but I'm trying to show you the thinking process of what you're trying to consider. So first of all, let's work with our numbers. 9, 3, and 39 all are divided by 3. So 3 can come outside of this long involved polynomial as a factor. If I take 3 out, that divides into 9 3 times. 3 divides into 3 one time here, so we would have a negative 1. And in this case, 3 goes into 3 one time, and 3 goes into 9 3 times, so it's 13. So that's a positive 13. Now we're going to look at our letters. The highest degree of x's that we can take out, we have x's in each of the 3 terms, is one of them. So that leaves 2 x's here. I'll circle the ones that we need so we don't miss them. In our y's, the highest degree of y's, they each have y's in them, but they have 2 in common. This one can spare 2. So we'll take out 2, 2, and 2. This one's still left though. And our z's are not evenly distributed throughout the 3 terms, so we have to leave those alone. Our crossouts are what comes outside. We've got 1x, we've got 2 y's, so that's a y squared, and that's all. So our greatest common factor would be 3xy squared. And that leaves, in the first position, it leaves a 3, x squared, z, minus 1, y, z. We don't actually need the 1. That is overkill, so we could just have it as yz. And then here we would have a plus 13. All of our letters are gone. They're already represented over here. So this would be the answer, but to check it, you would probably need to distribute back. Hopefully we can match what we started with. Let's see. So the first term, 3 times 3 is 9. We have x, 1 here and 2 there, so it's cubed. Y, just 2 of them, and the z. Next, 3, this is a negative, so we would have a negative. This is a positive 3 times a negative 1. That gives us a negative 3, x, y, we have 2 y's here and 1 y still left over, so that would be cubed, and the z. And then way over here to the 13, we're going to distribute what we took out back to the 13. 3 times 13 is 39. There isn't anything under with the 13, so I'm just going to copy what I have here, x and y squared. And let's hope it matches. So we've got 9x cubed y squared z minus 3x y cubed z plus 39x y squared. It worked.